All right, here we go. All right, now we already did section or examples. Let's see, we did 1, 2, and 3, right? And then we left off at example 4. Okay, cool. All right, just a quick recap because I missed you guys. I hope Futures Day went very well for you guys. So here's equations for an ellipse. Again, the major axis, if it's the x-axis, that means that term is going to be positive. Big difference between the two, between ellipse and hyperbola. With a hyperbola, there's going to be a subtraction between the two terms. And again, whichever of your terms, whether it's your x term or your y term, is positive, that is what term, or that's where your major axis is going to be. Okay? We looked at examples that just had centers of 0, 0. We still had vertices and covertices and major axis and foci and all that stuff. But remember, our covertices weren't actually a value on the hyperbola itself. It was a value that we referenced in order to draw this rectangle so we could draw an asymptote so we could draw the hyperbola. There's a lot of things that were connected together there, okay? All right, so then this is how these fell. Again, your vertices plus or minus A0, and then covertices were 0 plus or minus B when your major axis was parallel to your x-axis. And then foci plus or minus C0, that again goes with your x-coordinate because that is where our major axis is at. And then your asymptotes were plus or minus B over A. And remember, we found that by rate of change. We had a rise of a value of B because that's where our covertice was. And then we ran A units in order to get the edge of, connecting to that vertice itself. So that's how we found where our asymptotes were. Another major difference between ellipse and hyperbola. The equation that we used to find C for a hyperbola was C squared equals A squared plus B squared, whereas the equation that we use to find C for an ellipse is C squared equals A squared minus B squared, okay? So we said our A value was our biggest value, okay? Not necessarily the case when it comes to A and B for this equation, all right? All right, there's our quick recap. So we did a basic one where we just, picked out our values and then put them in a graph. And then this one required us to do a little bit of work because we had to divide 9 by both sides in order to figure out what those values were going to be. By the way, how do I know that this isn't a circle? It's negative between the two, right? Between the two, when you guys take your quiz, if it's positive, it's going to be a circle, okay? How else could I tell the difference between a circle and an ellipse? I'm getting ahead of myself. I was going to save this for the end.
Same coefficient for x and y.
Yeah, same coefficient for x and y, right? And then our ellipses are going to be equal to 1, okay? So when I divide to make sure they're equal to 1, I'll end up with different values underneath my ellipse, okay? All right, so we did this example as well too. Now, the next example that we do, example 4, is pretty similar to this. So when we did this example, we said, okay, we got two numbers that are multiplying to equal 6. So we wrote them as two separate equations. But then we just used some number sense and we figured, okay, well, I want to figure out which two numbers would multiply to equal 6 because these should be values on my graph. So then I graphed this ellipse and it was kind of tilted a little bit, but it ended up looking like this. So let's start by doing another example that's pretty similar to this. So I have x minus 2 times y plus 3 equals now, in this case, negative 6. So I'm going to want two numbers that multiply to equal negative 6. Now, first of all, we started by plotting asymptotes with the last example. Where are my asymptotes going to be here? I should have some asymptotes, right? At positive 2. Okay, what type of asymptote am I going to have at positive 2? Vertical or horizontal? Vertical, right? Because if x equals 2, then this product is going to equal 0, and it's not going to equal negative 6. Okay, so I can't have that. So then I'm going to have a vertical asymptote at 2. Where's my other asymptote going to be? Negative 3, good. So vertical asymptote, x equals 2. Horizontal asymptote, y equals negative 3. Okay, so negative 3. Looks something like that, okay? So now what I want to do is I want to figure out two values that multiply by each other to equal negative 6. Now, obviously, I've got x minus 2 and y plus 3 there. Those present a shift. Which directions am I shifting there? For the x minus 2, which direction am I shifting? It's actually going to be right 2. And then the other one is what? This would be down 3. Okay? And you can tell that based on our asymptotes as well too. Okay, so my asymptote shifted right to, it's opposite the sign that you would expect inside of your parentheses. Okay, all right, so let's make a table. What I'm going to do is I'm going to make a table, because I think this is how you've been instructed in the past. I'm going to make a table for x and y values and multiply to equal -6, ignoring the shifts. And then I'm going to do a separate table where I actually include the shifts as well too. So I'm going to shift all my values by going right to and then down 3. Okay. All right. So what are two numbers that multiply to equal -6?
-2 and 3.
You said what?
-2.
Okay. So -2, +3. What else? +2, -3. Let's do this. Let's try to keep this organized. Let's keep all of our, you know what? Whatever, Colin. I'll play your game. 2, -3. Okay. All right. What's another pair? Charlie? -1 and 6. And then coinciding with that? 6 and -1. Okay. All right. Yeah, it switches. What else could I do, though? I could do -6 and +1, right? But then along that same line, what else could I do? Oh, man, so I got a bunch, right? I got to revisit Colin's numbers as well, too, right? So then I've got -2 and 3, and then 2 and -3. Let's put 3 on the left side there. So 3 and -2, and then -3 and 2. We cool with that? All right. Now, the points that I actually want to plot are not those. I need to shift my values. Okay? So I need to go to the right 2, and then I need to go down 3. So what do I need to do in order to get those values? What do I have to do to my x values if I'm going to the right 2? Add 2 to each side, right? So I'm going to add 2 to all of my x values, and then I'm going to subtract 3 from all my y values, respectively. Okay, so then I would end up with, you guys tell me this is right, 0, 0 for the first one? Oh my gosh. And then for -6. And then add 2 to x would be 1, and then 6 minus 3 is 3. And then 6 plus 2 is 8, and then -1 minus 3 is -4. And then -6 plus 2 is -4, and then 1 minus 3 is -2. And then I would have 1 plus 2 is 3, and then -6 minus 3 is -9. And then 3 plus 2 is 5, -2 minus 3 is -5. And then -3 plus 2 would be -1, 2 minus 3 is -1. All right, let's plot all of these and see if we can get a decent graph going. I need a place to sit where I'm not in front of everybody. Charlie, I'm going to sit next to you. All right, so let's plot all these points. So 0, 0 is going to be my first point. I'm going to sit right here, pal. All right. I know, no offense to your table. I do. 0, 0 is the first point, and then 4, -6 would be like right over here. We'll see that a lot of these end up being symmetric about where my new center is. And then 1, 3, so right 1, and then up 3 is here. And then 8, -4 would be here. Okay, and then I would have -4, -2 is there. And then 3, -9 is down here. And then, let's see, 5, -5 would be right here. And then -1, -1 would be right there. So I'm looking at something like this. That goes in line with what I was expecting to draw. What about you guys? Okay. So that leads us into what an ellipse may look like when we have a center that is something other than our origin. So let's talk about that. Okay. So a couple things come into play with this, but obviously we are now introducing h and k. H and k. Now, the same thing is true where if our term that has x in it is positive, that is going to make our major axis now not the x-axis, but parallel to the x-axis, okay? So I'm going to say major axis parallel to x-axis. And then obviously over here, our major axis would then be parallel to our y-axis, okay? And again, we're dealing with the equation c squared equals a squared plus b squared when we want to find our c value, okay? All right, let's get into it. What's my center going to be?
HK.
Okay, so that's here. That is HK, that's my center. I wrote that very small. All right, now let's find our vertices, okay? In this case, our vertices are gonna lie along a horizontal line or a vertical line. Horizontal line. Since my x-axis is my major axis, my vertices are gonna lie along that line. Which means what about my coordinates? Which one of my coordinates stay the same? My k value. So my x value is gonna be something, and then my y value is gonna be k. All right? Now, how do I find the x coordinate of my vertice? I'm gonna start with h, right? H plus or minus what? Good. And then k. So those would be my vertices. H plus or minus a, and then k. All right? Now let's do my covertices. Again, not actual points on the hyperbola itself, but I use those points to help me graph this rectangle, okay? All right, that depends on what letter? I guess it depends on a lot of letters, really. But what new letter am I introducing into the mix to help me find my covertice? B, and that's going to affect which coordinate, x or y? Very good. So then my x coordinate would be what?
H.
God, you guys are so good at recognizing patterns. And then my y coordinate would be what? K plus or minus b. Good. So my vertices always start with h and k. If I'm moving them, then, you know, we'd either add or subtract a or add or subtract b. What's the length of my major axis? Still 2a. Oops, that's AA, which is something different entirely. So 2a would be the length of my major axis, okay? All right, foci. Depends upon what new letter that we haven't talked about yet. C, okay? Is that going to affect my x coordinate or my y coordinate? X coordinate, because it is parallel to the x-axis. And those lie beyond our vertices, okay? I should do this. Am I still writing in blue? Right in blue. Okay, so here's my vertices. And then my foci I'm going to do in green. So my foci are going to be here. Should have done those in blue, but whatever, okay? All right, so because of that, oh, there's a typo here. I'm going to have to fix that in a second. Okay. Charlie said that my c coordinate affects my x coordinate. My c value affects my x coordinate. So my foci x coordinate would be h plus or minus c. And then my y value is just going to be k. All right. Now, I want to figure out the equation of my asymptotes. Okay? It's still a linear equation. But now it's going to be different. Before it was just like plus or minus a over b or b over a. And I use that to find, based on my A and B values and where my major axis was at. But now I'm not centered at 0, 0, so I can't play that game anymore. I got to do something a little different. This is a fantastic time for us to use point slope form. Because I know that these are going to pass through what point? Yes. So then I can use h and k as my x1 and y1 in point slope form. You guys have point slope form memorized? It lives rent-free in your head? No? All right, well, let me write it down here. Y minus y1 equals m times x minus x1, right? My geometry kids took a quiz on that earlier this week, okay? All right, so I'm going to use h and k as my x1 and y1. My slope is going to be what I recycle, or I'm going to recycle it from my definitions earlier. I'm still going to go up a value of b and then write a value of a. So my slope is going to be a rise of b and a run of a. So I'm going to say my asymptote is y minus k, y minus y1, equals m, which is going to be plus or minus b over a times x minus h. Okay, so point slope form helps me do that. All right. There's a typo in here I need you guys to fix. There's something wrong with this formula. Can you guys spot it? I mean, I know it just looks like alphabet soup.
Is it the comma?
It's not the comma. Comma, chameleon. No, it's not the equals. It's not the squares. The A's and B's are fine. Oh, it's the only thing that's left. It's the H and K. H should always go with what coordinate? X. And then K should always go with Y. So,
That got me.
I'm sorry. So Y minus K and then X minus H. I was going to change it before you guys walked in, but I'm like, wait, these guys already downloaded the file, so that would be pointless. My center is still at H and K. And then my vertices, sorry, I should leave that up so you guys can see exactly what that changes. I apologize. Okay, so my vertices now, since my major axis is parallel to my y-axis because my y term has the positive coefficient, my vertices are going to lie along a vertical line, okay? And I should really put this in there. The equation of that vertical line would be x equals h, right? Okay, so my vertices, which coordinate stays the same, x or y? For my vertices. X. So then it's just going to be h, and then I got to play the game with k, right? So I'm going to do k plus or minus what value? Should be a. And then my covertices, here and here. Covertices would be h plus or minus b, and then my k value stays the same. Length of my major axis is still what? 2a. Let's talk foci. So those are then going to be on our vertical line. Those are our blue values up there. Okay. Speaking of k, that's what we're going to have to add and subtract with c, right? So my foci are still going to have an x value of h, and then my y value is going to be k plus or minus c. What is the only thing that's going to change for my equation for my asymptotes?
The slope,
The slope becomes what, Charlie?
A over B.
Good. So y minus k equals plus or minus a over b times x minus h. Okay, how we feeling? Fantastic. All right, let's do this example. We'll plot this, graph this, and then we'll go from there. All right, let's just dive right in. The term that is positive is what coordinate, x or y? Yeah, okay. So then that means that my major axis is going to be parallel to my x-axis, okay? So that means it opens which direction? Yeah, I forgot to call that out on the last slide, but it's going to open left and right. We talked about that before, okay? My center is going to be what? Good. 3, -1. Got to switch them signs. What's my a value? 5. B value? 4. I should find my c value. Can do that in a second. I'll do it right now. C squared equals a squared plus b squared. So c squared is equal to 5 squared plus 4 squared. So then I would get 25 and 16 added together is 41. Oh, nice, beautiful number. So then c equals the square root of 41. Nice little prime number there. Okay? Yeah. Wait, is that a thing?
Yeah.
God, dude, what is it, dude? I just can't. All right, it doesn't matter. Okay, so let's find our vertices. So I know that my center is at 3, -1. Of all the numbers. Wasn't that like the original one? All right, I don't even want to know anymore, honestly. Was it? Okay. Okay, so I'm going to add and subtract my value for a to which coordinate, x or y? X, because it's parallel to the x-axis. Okay, so then I would have 3 plus or minus my a value of 5, and then -1. We do need to chase that into 2 individual vertices. So then we would have 3 plus 5, which is 8, negative 1, and then 3 minus 5, which is negative 2, negative 1. So 8, negative 1, negative 2, and negative 1. Put those values on there. All right, super. Covertices are going to affect which coordinate? My y, right? So my x stays the same, 3, and then I'm going to do negative 1 plus or minus my b value, which is 4. So then I would have 3. Negative 1 plus 4 is going to give me 3. And then 3, negative 1 minus 4 is going to give me negative 5. So 3, 3. And then 3, negative 5. Okay, super. Now what I can do is draw my rectangle in there. I'm going to do that. Okay, so it looks something like this. Okay, and then, length of my major axis would be 2 times a, right? 2 times 5 gives me 10. Okay, so then now I need to find my foci. So that is parallel to my x-axis. So then it's going to affect my x-coordinate. So then I would have 3, my h value, plus or minus square root of 41. And then my y value, negative 1, stays the same. Now, square root of 41. That is around what value? 6 point something, right? Okay. Brother! All right, so then in that case, I would go 6, a value of 6, then point a value of 7 to the right and then to the left. So 1, 2, 3, 4. When I read my room code yesterday out loud, it had 6, 7 in it. So I said that, and everyone laughed, and I'm like, you got to be kidding me. All right, so either way, there's those. Let's do our asymptotes. We'll do that real quick. So y minus y1, which would be our k value, which is negative 1, so y plus 1, equals, okay, is it b over a or a over b? B over a. So my b value is going to be 4 over 5, so plus or minus 4/5, and then times x minus 3. Okay, so asymptote here, asymptote there, here, there, and then I draw my hyperbola. I really wanted to do another example with you guys, but I will not have time. I will briefly show you. The next example, though, just has you guys complete the square. So we remember the process of completing the square. So it would have you guys complete the square in order to then get it into that form and find all of your information. What did I do? Oh, I did the other way, didn't I? That's why I heard no. Oh, I'm so sorry, guys. That's why technology exists. I just pressed that back arrow a bunch of times. Can I do that with my life instead? Of the hyperbola? I'm just kidding. I would still be here with you guys, for sure. And I would still have my family. What would I take back then? I don't know. I'm happy to be where I'm at. Okay.
All the times you put 6, 7 in there.
Yeah, there it is. So I'd change my room code. That's what it would be. All right.